It seems as though you have not as much exposure to MATLAB as I had thought. So I'm going to show you how to get the values that you need from your data to produce your slides for this second project. So one of your classmates was kind enough to let me use their data. So I'm just going to plot that data. Eventually, there it is. So this is the pressure sensor. So here we have steady state at ambient conditions, then they added a pressure to it. We had a new steady state, and then they released the pressure. So what we want is the average here, and the standard deviation here, the average and standard deviation up here, and the time it takes to go from when the pressure was changed to 95% of the new mean. So I'm just going to use the MATLAB command window. I'm not going to write a program for this. So the first thing I want is, let's find the indices of the matrix. So we've got these two, well, vectors really, time and voltage, and I want to find where time is less than. So I'm going to take a look at the plot and see where they put their change. I don't know exactly where they put their change. I'm going to assume it's 17 seconds. Around there, 17. So those are all the vectors that, all the indices that in which time is less than 17. But what I want is the voltage when time is less than 17. So if I put those indices into the vector v, I get all those voltages. And you're asked to get the mean. So mean equals that. Let's call this mean 1. And you're also asked for the standard deviation. Call that S1. Now you're also asked for the mean and standard deviation after the system had reached a new steady state, so up here. So let's say that it reached a new steady state between 20 and 36 seconds. So now we want to find, I'm just pressing up to, so if I press up it'll go to the previous things I've typed in. So now if I look at, I want to look at mean 2, and now I want to look at time greater than 20, I think I said, and time less than 36. So that's our new mean at the new values, and let's get a new standard deviation, STD. Yes. There. So we go from a mean of 2.5 up to 2.54 something. And we can see it's much noisier. There's much more noise in the signal when there's no pressure on it, which kind of makes sense, and the noise goes away when we put some, well, it diminishes as we put more pressure on the sensor. So now we want to know the time it takes to go from when we first make the change at 17 seconds to 95% of the new mean. So we need to know the span. So let's say span, or let's say SP equals M2 minus M1. So that's how many volts it needs to travel to get to the new value. But we only need to travel 95% of that, so times 0.95. And we need to add that to the original mean. Let me bring this up. So the span is the distance from here to here, and then this value here that we're going to calculate, let's not even call that span, let's call this limit, or lim, is the number of, is the voltage at which it hits 95%, which is 2.54. So 2.54 is right there. So we want to see what is the earliest time at which the voltage is equal to that value, or equal to or greater than that value. So we can go back to find v greater than the limit, and that gives us the indices where that's true. And we want the earliest time where that's true, so just look at time, and it is, where is it? Right there. Control V, 19.43 seconds, and subtract that from 17, which was my best guess at when change was applied, and so the answer is 2.4345 seconds. I hope that helps.